So, for this problem, we've got some function right here, and we need to figure out the change in y for each of these problems, assuming that it has initial position of x. So you can think about it like the change in position. So let's do the first one here. We want the change in the y. Okay, well, how are we going to get that? Well, the change in the y is given by the following. Our first point is going to be 2 something. So I got to take 2 and I got to plug it in here. So 2 times itself is 4, times 3 is 12, plus 2 is 14. So do you agree with me that if you plug in 2 into this function up here, if you plug in 2, you get 14 out? Now our change in our x is 0.5, which means we're going out from 2 to 2.5. So if you think about the function, I don't know, it's got some kind of curve like this. Here's 2 at a height of 14. Now we're going out to 2.5. And the question is, what is its height? So we'll take 2.5 and we'll plug it into this function up here. So we've got 3 times 2.5 squared plus 2.5, which gives us 21.25. So 21.25. Now the change in y is this length right here. It's this minus this. So if we take that number and we subtract 14 off of it, we get 7.25. Just like that. And that's it. That's all there is. So if our x value changes by a half, our y value changes by 7.25 or 7.25. Okay, so that's the picture of what's going on here. Now we just need to go ahead and compute this for the rest of these. So for the first one, our delta y was 7.25. Now let's go ahead and check it for the next one. The x value of 2 maps again to a y value of 14. But now our change in x is 0.01, so we have 2.01 for our x value. Okay, so we got to go ahead and plug that in. And I'm getting 14.1303. And so the change in the y was 0.1303. That's the change in the y value, right? To go from here to here, we changed by this much. Okay, we got 2 more to go. So what's the change in y here? Well, we started at 4 and we plugged 4 in. We get 52 out. And so our change in our x is 0.1. So now we'll plug in 4.1 and we get 54.53. And so our change in our y is 2.53. Okay, and lastly, down here our change in our y, again if we plug in 4, we end up getting 52. And our change in our x is 0.01, so we'll plug in 4.01. And now we'll see what we get out here. I'm just going to type it into the calculator. I'm getting 52.2503. And so your change in your y value is 0.2503. Now here's the important thing to notice. The change in the y for both of these, compare the change in the y between here and here and the change in the y between here and here. Both had an initial starting value that were the same. 2 in this case and 4 in this case. Notice that as change of x became smaller, the change in y also became smaller. Okay? And that's what we would expect. We'd expect as change of x becomes really small, change of y becomes really small. Like for example, if you were taking a look at a person running, okay, down the road, if you started, if you looked at them at time equals 0, and then you looked again 3 seconds later, their change in distance would be a lot higher than if you looked at them at 0 seconds and then again at 1 second, right? So this is, think about this as our change in our x variable, and think about these, the distance that we move is the change, excuse me, the change in our y value. So notice the change in the y value, okay, the total distance that we move wasn't as much with the change in the different x values.